Day 2, we're going to take a look at independent and dependent variables. We'll start with the warm-up. 3 days in a row, dog's owner tied his dog's 5-foot leash to a post outside a store while he ran into the store to get a drink. Each time the owner returned within 5 minutes. The dog's movement each day is described here. Day 1, the dog walked around the entire time while waiting for its owner. Day 2, the dog walked around for the first minute and then laid down until its owner returned. In day 3, the dog tried to follow its owner into the store but was stopped by the leash. And then it started walking around the post in one direction. It kept walking until its leash was completely wound up around the post. The dog stayed there until its owner returned. Each day, the dog was 1.5 feet away from the post when the owner left, and each day, the 60 seconds after the owner left, the dog was 4 feet from the post. Okay, so let's mark that, what I highlighted here. 1.5 feet away when the owner left, so times 0, and then at 60 seconds, 4 feet away. Okay, let's try drawing these situations. So we'll start with day 1. The dog walked around the entire time while waiting for its owner. Okay, so walked around the entire time would mean, so if it's flat, it's staying still. We don't want our graph to be flat, so maybe we go up, and then we could go like down, back up. So as long as it's not like complete, here, the dog kind of turned around there, but it's not completely flat, so that could be an example of day 1. I'll put day 1. All right, day 2, let's do in purple. All right, so this one could start the same way. So walked around for the first minute, but then stayed. That would be day 2. And then day 3, the dog tried to follow its owner into the store, but was stopped by the leash. Okay, so the leash was 5 feet long, so maybe something like this. Stopped by the leash. Then it started walking around the post in one direction. Okay, so stop by the leash, and then if it walked around the post in one direction, so it's going to get closer. So I imagine like spiraling around the post. It'll get closer. I don't like this graph right here. So it goes up to 5 feet, then has to go closer and closer until was completely wound up around the post. So, okay, there's 5 feet. So something like that, day 3. Okay, so we'll take a look in class what your graphs look like. And then we'll get to this idea of independent-dependent variables. So it says, from the graph, is it possible to tell how many times the dog changed direction while walking around? Explain your reasoning. So we'll take a look at your graphs in class, and we'll talk about, like, can you tell when it's changing direction by your graphs, by distance from the post in feet? And then we'll look at the idea of functions. The relationship between quantity of time in seconds, since the dog owner left, and total distance. So we have time and distance in feet is called a function. In that function, which variable is independent, which is dependent. Okay, so dependent means it depends on the independent variable. And I would say distance from the post. This is dependent because it depends on the time in seconds. And what you'll start to notice is the independent variable in a graph is always the x-axis, and the dependent is the y. So the y variable depends on the x here. Distance from the post in feet depends on time in seconds. So independent is time, dependent is distance. Write a sentence of the form blank is a function of blank. Okay, so distance is a function of time. A relationship between two quantities is a function if there is exactly one output for each input. We call the input the independent variable. I should really use different colors here. Okay, so again, time is independent. And then the dependent variable is distance here. And that's called the output. Nope. And the output is called the dependent variable. Okay, so again, there's the two things here. The idea of a function. For every input, there's only one output. So if you take a look at our graph here, for every time, there's only one distance away from the post that the dog can be, right? You can't be in two different places at once. So again, for every input, for every time, there's only one distance away from the post. So it's a function. And then the idea of independent and dependent variable, the dependent variable depends on the independent variable. So let's write some of these. It says, given the following statements, complete the sentences below for each pair. So we need to do independent, dependent variable. What is a function of what? And so again, we'll put our dependent here and our independent over here. Okay, so for example, let's find some. I'm going to circle one. Let's look at results of a soccer game. What does that depend on? Who scores more goals? Okay, so again, the result of the soccer game is a function of who scores more goals. Okay, so whoever scores more goals, that's the independent variable, and then who wins, that depends on who scores more. Let's do another one. How about cost of a speeding ticket? What does that depend on? Cost of a speeding ticket depends on the speed at which you are driving. So we say that cost is a function of speed. Speed would be the independent variable, and then the cost of your speeding ticket would be dependent on that. Okay, let's do another one. How about how tall the grass grows? Ooh, I used a different color. Let's use blue. How tall the grass grows is going to depend on what? How much rain falls. So we say that the grass height is a function of the rain. Rain is it'll rain, that's the independent variable, and grass is going to depend on the rain. So in class, we'll be filling this out, and then we'll be taking a look at some more examples of functions. So the first one, it says the relationship between the amount of time a car is parked in hours and the cost of parking can be described with a function. What's the independent variable and what's the dependent? All right, so I would say that the cost depends on the amount of time that you are parked. So the independent is time, which usually time is independent, not always, but usually. And the dependent variable is cost. Cost depends on time. Describe the function with a sentence is a function of. Okay, so we can say cost is a function of time. Suppose it costs $3 an hour to park with a maximum cost of $12. Sketch a possible graph of the function. Be sure to label the axes. Okay, so again, the independent variable is the x-axis, and then we'll put cost here. I'm going to make a little table because I think it's easier for me to get these coordinates. So we'll do time and cost. $3 an hour to park, so 0, 0. After 1 hour, it's $3. $2, it's 6. $3, it's 9. $4, it's 12, and the maximum is 12. All right, let's graph this. What should we scale our graph by? Time, I'm just going to go up by ones. 1, 2, 3, 4, 5. And then cost, I have to go up to at least 12. 2, 4, 6, 8, 10, 12. Okay, go by 2s. 2, 4, 6, 8, 10, 12. Okay, let's graph our coordinates. 0, 0, 1, 3, 2, 6, 3, 9, 4, 12, 5, 12, 6, 12, 7, 12. Okay. Now, should we connect the lines? So think about if we connected the lines, if you were parked there for like 2.5 hours, would it cost you in between $6 and $10? And it just says let's see, $3 an hour to park. So it would make more sense for this one to use the dots because you'd only be paying by the hour. Okay, let's take a look at number 2. The prices of different burgers are shown on the graph at the right. Based on the information from the menu, is the price of the burger a function of the number of patties? Explain your reasoning. Okay, so does the price depend on number of patties? So if we take a look at it, we can see that one patty is $3.49 with a cheese slice. 2 patties, $4.09. 2 patties, $4.59. So if we're looking at just the number of patties, here you have the same input, 2 patties, but you have a different price, right? So we can't say it depends just on the number of patties. It's going to also depend on the cheese. So we can say no, it doesn't depend on just the number of patties. It's not a function. A function is for every input, there's only one output, and we can see when there's 2 patties, we have 2 different prices, and that makes it not a function. So we would say no, because for 2 patties, you're getting 2 different prices. If it was a function, whenever you see 2 patties, you should have one price, the same price. All right, and then 3, the distance a person walks, d in kilometers, is a function of time, t in minutes, since the walk begins. Select all true statements about the input variable of this function. Okay, so again, time is the independent, distance is the dependent. So time is the input. Okay, we can circle that one. Distance is not the input. Time since the person starts walking. Oh, okay, so I was wrong. It's not time of day. It's going to be time since the person starts walking is the input. T is the input, sure. D represents the input, no. The input is not measured, no, that's not true. The input is measured in hours. Nope, it's in minutes. And for each input, there are sometimes 2 outputs. No, because you can't be in 2 different places at once. So here there's only 2 statements that are true, C and D. So your assignment then to kind of practice this idea of independent, dependent variables is on Desmos. So the link should be in Schoology. Also, if you go to your student Desmos account, it will be there as well.